I thought I would give all my new COVID technology a try. So first off, let's look at regression in Minitab. I've got some data here from a major U.S. retailer, and they think that sales predicts profit. I'm just covering simple regression here. So I like to look at a scatter plot, or you can get this really cool fitted line plot. But let's do a scatter plot first. So scatters plot, simple. And EBIT is my Y because that's what I care about, and I think that sales is the predictor. All right, Minitab gives me a nice output here. Beautiful visual. And of course, the major thing we care about is looking for relationships. So let me come over here to my other cool new toy, the bamboo pad. So basically, what we want are, in this case, a strong positive correlation. Like I'm going to do double positive to say that, man, every time comp sales goes up to a point, we get the exact same movement in EBITDA. Now, remember, regression is saying, it's not saying that, how do I want to say this? It's trying to explain how much of the movement in the X, all right, explains. So if I go from 0.2 to 0.4, do I get sort of that same movement in profitability? It doesn't have to be one for one. So for example, if every 1 point in comp sales got me 5 points in EBITDA, right? So the next move was 2, then I would have 10. The next is 3, I would have 15. Well, then that would be an R squared of 100%. R squared is the statistic that we want to use in regression. It explains the movement of the X's ability to explain the movement of the Y. Clearly, in this example, you want a strong positive. Now, over here, I'm also exploring, in this example, alternatives to Minitab, and this is something called Jamovi. So let me go over there and run that. I believe this is it. Yep. I'll go over here to Jamovi. And I went into analysis, regression, correlation matrix. I want to look at comp sales and EBIT. You can come down here and ask it to give you the plot. All right, now we've got our good stuff up here. We've got our p-value and a few other things going on. R squared is really what we care about in regression. And so there you go. Took that same graph over here to my cool bamboo feature, and you see that here it's giving us sort of the same plot. So strong positive was what they wanted. Clearly we would not want what's called a strong negative, right? Double negative there, not the equal sign. That would say that every increase in sales we got a loss, right? So that would be the other direction. We got a loss. So what did we get in this example? We got what we call in the South a turkey shoot, which means a shotgun shot a piece of paper and just put holes everywhere. There is no rhyme or reason in a relationship between sales and profit, which is surprising to most, but not to me. I've done so much work in retail. With big companies, there's almost no correlation between sales and profit. It's sort of like you have to have sales to have a profit. I mean, look at this company right here. This company, this store grew sales by almost 11%, and they had a negative profit. This store right here had negative sales growth and had almost 5% profitability, okay? So this says that something else besides sales is driving profit. So remember that, you folks that are always saying that we just need to sell more to make the company look good. No, by the way, I would argue this is why if you look at companies that do massive layoffs, their stock price usually goes up, and that's because one of the things that we truly know that drives profitability is cost. So Jamovi, I like it here. It's doing the same thing. It just did not allow me to go pick scatter plot specifically. I had to, as you saw, go in there and request this correlation matrix. there's all sorts of neat stuff. I'm still kind of playing around in here. All right, let's look at one where we do have a relationship. So I'm going to go in here, and this is an example where my engineers have told me that this number predicts the weight of a tree that we've cut down for timber. So go over here to the graph scatter plot. All right. And we just want to see if, in fact, weight is my y, and this factor that they've created predicts it. Or do I have some smart engineers? And I would argue, let me move this, that I, in fact, do. Boy, that looks great. So let's go over here to my cool bamboo notebook and discuss it. We have here what we call a strong positive correlation. Look at the r squared. The r squared says how much, again, of the movement in the x explains the movement in the y. Okay, that's the key. That's why I disagree with the use of discrete data in regression, because when you go from cat to dog, well, there is no variation. But you go from 1.3 to 4.5, that is variation. So, but clearly my engineers are onto something. This is probably an outlier. I have done this test before. If you pull that out, that might be a dead tree or something that somehow got in the data set. The r squared goes up dramatically. So excellent model. Good job, folks. Let's see if I brought that over from Jamovi. Nope, I've not done that yet. So let's go look at that in Jamovi. I'm going to go here and let's run it. We're going to go regression. And again, I have to do correlation to see we want to know if weight and D2H are related. There's a discrete variable, by the way. And look at that. We get a nice p-value less than, really low. Excellent scatter plot. And just for fun, if we want to get that r squared, we would have to go back and run the regression. I'm just going to assume it's linear. So we've got, does weight, my dependent variable, I like how they highlight that. Is it predicted by this factor? Okay. And if you wanted to plug site in there, that's where. So there's our excellent r squared. By the way, let's do that. Let's just do that for fun. The site or the location that the trees were grown. All right, and you can see whether or not that has impact. Okay, let's see, site's p-value. Nope, it does not have any impact. The p-value is greater than 0.05. So, what did we practice with today? We practiced with, I'm loving this. Whoops, sorry. We practiced with Minitab. And yes, that's an N. Then we did this free, that's the keyword, free software that I'm trying to find. Because if people don't have to buy software, that's nice. This seems to have some limitations. Minitab is very good at teaching students how to do statistics. This one you kind of already have to know a little bit. And then we learned that there are strong positive correlations. Then we have what are called positive correlation. It's not perfect. We used to call it kind of the fat pencil test, but there's a little outlier over here, but there definitely seems to be a relationship. So that's our positive. And then we have the no correlation, which Lee calls the turkey shoot. I feel like there's an E in there, but I cannot spell and write at the same time, so don't laugh at me. And I'm being humble and admitting my weaknesses. Then we've got the beautiful negative correlation, strong negative. That's like putting pressure on the brake and the stopping distance of your car. And then we just have sort of, things are moving nicely together, which is negative. And there you go. That's what we learned today in just a matter of a few minutes. So I hope you enjoyed it, and I'll see if I can't make you something else.